Now, in section 1 of chapter 2, we talk about graphing in general. Now we're going to look more carefully at equations of lines. And if I were teaching this class, I would hand out a special sheet of the general equations that relate to equations of a line. Now, in the last section, we talked about standard form, and that will be mentioned a little later, and also slope-intercept, which will be mentioned here as well, and point-slope form, as well as slope itself. So as you take notes on these lessons, whether in class or from this video or reading the textbook yourself, you're going to be writing these down and highlighting them, because this is what you need to know to do well in this type of work. So let's go on. We're going to take a look first at slope. Now, there is a general formula for slope that I'll write here, and would be one of the formulas, that m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And slope is often referred to as a ratio of y units to x units, which is a ratio of rise over run. Now, if we look at a graph, we can almost pick the slope up by saying, getting some point on the grid line and another one there, and then making a right triangle, and then just counting the units. So let's do it for this one here. Y units over x units. Now notice if I start here, I'm going in a negative direction. So I'm going here 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a negative 9 here. Then I'm going to go up, and I'm going to count from over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the slope of this line, and going up is a positive direction, is a negative 13 over 9. Now if I use this ordered pair here, and this ordered pair, and put it into my equation, now I'll use these as my negative 2 here. So this is going to be 6 minus, and this is a negative 7 here. So notice I had to use parentheses to protect my signs. And then now a negative 5 minus 4. Now notice what I get here. This is going to become a positive 13, and this is going to be a negative 9. So I can use ordered pairs that are along the line, or I can make this triangle and physically count the units. Now if I started here and went down, that's a negative direction. So our 13 would have been negative, and then going this way it would be positive. Or as I started here, negative, positive. When it starts high on the left, and as you go to the right goes down, this is negative slope. And you'll be practicing that. So there is the slope formula. And there is the example we did. Now, you might say, does it make a difference which ones you designate as the sub-2s? No, it's just that you can't mix them up. So I usually take the second one as the sub-2s and sub-1s. And being careful when there's a negative sign in the sub-1s, that the opposite of a negative make this a positive. And the usual place to put the negative sign is by the division bar that we mentioned in chapter 1. And you'll be practicing this. Two other equations that I would have had on the form of equations is y equals b and x equals a. You recall b is our y-intercept. So if they give you an equation, y equals negative 4, or this equation x equals 3, these are special equations. The equation of y equals b is the equation of a horizontal line. And we plot it. This was the equation they'd give you, y equals negative 4. You would go down to negative 4, put a dot there, and then any place else put another dot, and that would be your horizontal line. But here they're asking us, what is the slope of a horizontal line? And if you put some of these points into your formula, you end up with m equals 0 over 5. Well, any number divided by a non-zero number is 0. So the slope of all horizontal lines is 0. Now how about a vertical line? Here the equation is x equals a. X equals 3 will be your x-intercept at 3. And then any other point gives you a vertical line. But what is the slope of that line? Well, again, when you put it into the slope formula, you end up with m equals 3, in this case, divided by 0. Now, anytime you have something divided by 0, we say that is undefined. Now, students can get these mixed up. Again, if you have the work done correctly on your blue sheet, I can give you, or I'm sure your instructor may give you, partial credit. But you need to pretty much fix into your memory that 0 divided by any number other than 0 is 0. And any number divided by 0 is undefined. And the slope then of a vertical line is undefined. All of them. So special cases, and you want to include this in your notes and then study that. Now here they're introducing the slope-intercept form that we mentioned in section 1 of chapter 2, and should be one of the formulas. Y equals mx plus b. When it's in this form, whatever value you have for the b is where the line will cross your y-axis. This is called the y-intercept. And then any value you have for m, and remember that's over 1, will be your slope. So, given this information, it gives you a unique opportunity to graph them. You would graph your y-intercept first, then depending what the run is, you would put that in and then do the rise and get that second point, and in MATLAB that gives you your graph. So a very important equation, put a star by that. Now, when it's in this form and they're asking you to define what is the slope, well, whatever's in the m position. What is the y-intercept, whatever is in the b position. Now here they're saying find an equation for the line with this y-intercept of this and the slope. So again, you would take the slope, put it in front of the x where the m is, and put your y-intercept there. And there's the equation. Now, find an equation of a horizontal line with a y-intercept of 3. Well, remember, your slope of a horizontal line is 0. So basically, it's y equals b, which is your y-intercept. So we had covered this a little bit already. Okay. Now, they're using the formula y equals k, k for a constant. Again, other books use y equals b. I like that one, but this is the one they'll sometimes use. Okay, find the slope and y-intercept of each of the following lines. Now, I don't know if you recall another famous equation of the line is standard form. ax plus by equals c, which is the form this is in. Now, to find your y-intercept and slope, we have to solve for the letter y. Okay? Now, a couple of ways to do it. They do it one way here. I'll show you another way. I'm going to take my y because I want it positive, and I'm going to move it over to this side. I have 5x, moving my negative 3y over, making it positive, and this transposes like so. Now I divide everything by 3, and then I can rewrite it. Y equals 5/3 x minus 1/3. Again, they're doing it a little differently, but that's satisfactory as well. My slope, then, is the numerical coefficient of x, and my y-intercept is in the b position. All right, let's do letter B here. Negative 9x plus 6y equals 2. Well, my y is already positive, so I'm going to transpose the x, and I get 6y equals 9x, and the 2 is already over on that side. Divide everything by 6. I get y equals, simplify that, 3/2 x plus 1/3. So my slope is 3/2, and my y-intercept is 1/3. My slope is 3/2, and my y-intercept is 1/3. I like this because they're showing you relationships of slope. Here for this one, and by the way, all the y-intercepts are 0. So for this equation, this is going to be y equals x. Because what's the slope of this line? 1. This one, y equals, now our slope is 1/2 x. This line is y equals 3x, and this line y equals 7x. So which line has the greatest slope? Again, the steeper the line, the greater the slope. And these are all positive slope. As you start from the left and go to the right, the lines go up. Okay, all of these have a y-intercept of 0 that we don't write. All going through the origin. So this one would be over 2 up 1. This one is over 1 up 1. This one's over 1 up 3. Over 1 up 7. All over 1. And this is over 2. Alright, very good slide there. Here's a little summation of slope. Positive slope, again, starts low, goes up. Horizontal slope is 0. Negative slope starts high and goes down. And then vertical line, the slope is undefined. Now for example 7, they want you to find and label the x and y intercepts. So one of my little inventions that you may or may not remember is this x and y intercept t-chart. This will be your 0, comma b, your y-intercept, and this will be a, comma 0, your x-intercept. So we just take it right from this equation. If x is 0, y is going to be 5/2. If y is 0, x is going to be 5. Now when you graph that, and you'll be using your Math Lab to do it, 1, 2, 3, 5/2 is 2.5, so right there, and then 5, 0, 1, 2, 3, 4, 5. You have plotted the y-intercept, the x-intercept, and then just by doing those two spots, you get your graph. Okay? So, again, this is your y-intercept, this is your x-intercept. Math Lab want you to graph it this way. So you click on the y-intercept, move your line down there, click again there. You have plotted the intercepts. And there is your graph. Okay, now they're giving us a little bit more background. And I have these on that little sheet that I would use. I call them Formula 7 and 8. Here it is. Take some notes. If your slope of the first equation equals the slope of the second equation, but your y-intercepts do not equal each other, we say the lines are parallel. They will have the same slope and different y-intercepts here in a sense. Now, we also have that if they have the slope of one and you multiply it by the slope of the other, and the product of that is a negative one, the product of the slopes, such as 1/2 times a negative 2/1, which gives you a negative 1, then these lines are perpendicular to each other. So if you were to solve an equation for y, and then you get mx plus b, and two equations, you compare the slopes, compare the y-intercepts. The slopes are the same, but the y-intercepts are different, the lines are parallel. If the product of these two slopes, once you do it for the other equation, is a negative one, then the lines are perpendicular. We see a little bit of it there. And that's the background for this. So, part of it would be to solve the equations for y and compare the slopes. Now, one of the last equations that we're going to be using is this one called the point-slope form that is listed right here. And basically, this form states that if you know the slope and you know one point, you can substitute the point there and the slope there into this equation and generate usually either in standard form or slope-intercept form. And depending upon which they ask for in the problem you're dealing with, you can convert one to the other. So let's take a look at one here. And they say, here's the slope, and there's one point. And they're putting it in the equation, substituting. They then get y equals 2x plus 1. Okay, here's another. The slope is negative 3. There's the point. They put it into the equation, and there you get it. So I could write all this out for you, but you can pause it, and you'll be trying it out in your math lab and your Quizmes. Now, in this one, they kick it up a little bit because they don't give you the slope. But now they give you 2 points. So you have to carefully use the slope formula to find the slope. Then you can choose either of these points to put into your point slope form. And they've chose here the 5 and the 4 after they found it. And there's the equation. And they're showing you the graph of it. Now, whenever they ask you to find an equation of a vertical line, this ought to be easy. And you might say, well, why is it easy? Because if you remember that the equation of a vertical line is x equals a, and they want a vertical line to go through 2, 3. This ordered pair, by the way, is sometimes written a, b. What do you think your equation is going to be? Well, it's going to be x equals 2. But here they're saying they want it to go through a -1 and then some other point up here. It doesn't make any difference. 5. So for this equation, it's going to be x equals your a value, -1. So again, using equations that we've been working on. Another modification of this is write an equation of a line that has undefined slope. That's a vertical line. They're just asking it a different way. Now, I don't know if I skipped it, but if they ask for an equation of a horizontal line going through this point, remember this is a, b, and the equation of a horizontal line is y equals b, your equation would then be y equals 4. Just as a vertical line would be x equals 3. Okay, now they're giving you a little summary of formulas. Remember, we like to have this as x equals a, y equals b. There's your y-intercept. There's your point slope. And there is standard form. They're using the lowercase letters. That's fine. Okay, I think we're just about finished here. Good little review. Well, they're going to give us an application here. So, again, you would read this. This is in slope-intercept. There's your y-intercept right over there. I don't know what they're doing there particularly. There's the slope. And they want you to substitute an 11 for the x, and you get your answer there. And if you started in the year 2000, then if x is 8, then that would be 2008. Again, you'd have to read this in more detail. I'm not going to take time to do that. And here's a case where they're giving you two sets of data. You have to find the slope, which is this, and then use the point slope form to develop your slope-intercept equation, and then use this to actually get some results. And there we go. Again, we're trying to keep these to about 30 minutes. A lot of good stuff here. You'll be doing your practice, your quiz bees, and then there's just one more section in Chapter 2.